the James Webb Space Telescope, the most powerful telescope ever built. It's giving us a new perspective on the universe, a perspective we've never had before. Webb sees the universe in infrared light. This lets it peer through clouds of gas and dust, clouds that would normally block our view. With Webb, we can now see things that were once hidden from us. This incredible telescope is allowing us to peer deeper into the cosmos than ever before. It's revealing secrets about the universe that have been hidden for billions of years. Get ready for an incredible journey because Webb is just getting started. At the heart of our Milky Way galaxy lies a mystery, a supermassive black hole known as Sagittarius A*, millions of times more massive than our Sun, an invisible giant warping the fabric of space-time. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. They are enigmatic objects pushing the boundaries of our understanding of physics. Sagittarius A*, our own local supermassive black hole, is a powerful source of energy and fascination. Although we can't see the black hole directly, we can observe its effects on the surrounding stars and gas. And what Webb has seen is truly spectacular. The James Webb Space Telescope is a marvel of engineering. One of its most important features is its ability to see infrared light, light that is invisible to the human eye. Infrared light can penetrate through the thick clouds of gas and dust that obscure our view of the center of the galaxy. This is why Webb is so important. It's giving us our first clear look at the region around Sagittarius A*. Imagine being able to see through walls. That's what it's like for Webb with infrared light. It's giving us X-ray vision into the heart of our galaxy. What Webb has revealed is a dazzling light show, a cosmic ballet of gas and dust swirling around Sagittarius A*. The gas is heated to millions of degrees as it spirals inward towards the black hole. This superheated gas emits intense radiation, visible to Webb's infrared eyes. Imagine a whirlpool of glowing gas, spiraling faster and faster as it gets closer to a drain. That's what's happening around Sagittarius A*, but on a much grander scale. This is not just a pretty picture. It's a window into the mind-bending physics that happen at the edge of a black hole. Echoes of light deciphering the signals. The light show isn't just a constant glow, it flickers and flares, changing over time. These changes tell a story. They are echoes of the black hole's feeding habits, revealing how Sagittarius A* interacts with its surroundings. Imagine listening to the echoes in a canyon. You can learn about the shape and size of the canyon by how the sound bounces around. That's what astronomers are doing with the light from Sagittarius A*. By studying these fluctuations, astronomers can learn about the size and spin of the black hole, as well as the properties of the gas and dust that surround it. The dance of gravity and light. The light show around Sagittarius A draws in nearby stars and gas, creating a spectacular display of light and energy. As these celestial bodies spiral closer, they accelerate and emit powerful radiation, illuminating the surrounding space in a dazzling array of colors and patterns. The immense gravity of the black hole warps the fabric of spacetime, causing light to bend and distort as it passes by. This warping effect is a direct consequence of the black hole's mass and the curvature it creates in the spacetime continuum. The closer the light gets to the black hole, the more pronounced the bending becomes, leading to fascinating visual phenomena that captivate astronomers and physicists alike. Imagine a bowling ball placed on a trampoline, causing the fabric to sag. This simple analogy helps us visualize how a black hole deforms spacetime. The heavier the object, the deeper the sag, and similarly, the more massive the black hole, the greater the distortion it causes in the fabric of spacetime. This analogy, while not perfect, provides a tangible way to grasp the complex interactions between mass and gravity. That's what a black hole does to spacetime. It creates a well so deep that not even light can escape once it crosses the event horizon. This boundary marks the point of no return, beyond which the gravitational pull is so strong that escape becomes impossible. The event horizon is a defining feature of black holes, and it plays a crucial role in the dramatic interactions we observe. And just like objects rolling on the trampoline would follow the curve, so too does light bend around the black hole. This bending of light is not just a theoretical concept, it has been observed and measured, providing strong evidence for the predictions made by general relativity. The paths that light takes around a black hole can create stunning visual effects, such as rings of light known as Einstein rings. This bending of light creates a phenomenon known as gravitational lensing, magnifying and distorting our view of objects behind the black hole. Gravitational lensing allows astronomers to study distant galaxies and stars that would otherwise be too faint to observe. By acting as a cosmic magnifying glass, black holes and other massive objects help us peer deeper into the universe, revealing the hidden wonders of the cosmos. A feast for the cosmic giant. The swirling gas and dust around Sagittarius A* aren't just dancing around the black hole. These particles are caught in a gravitational ballet, moving in intricate patterns that are dictated by the immense gravitational pull of the black hole. They're being pulled in, spiraling closer and closer until they eventually cross the point of no return, the event horizon. This is the boundary beyond which nothing, not even light, can escape the black hole's grasp. Imagine a giant vacuum cleaner sucking in everything in its path. The black hole's gravitational pull is so strong that it can draw in gas, dust, and even entire stars that venture too close. That's kind of what a black hole is like. It's an insatiable cosmic giant, constantly feeding on the material that surrounds it. It's constantly feeding on the gas and dust that surround it. This process is not just a simple act of consumption, it's a complex interaction of forces and energies. This process of a black hole consuming matter is called accretion. The material forms an accretion disk as it spirals inward, heating up and emitting intense radiation. As material falls into the black hole, it releases an enormous amount of energy, heating up the surrounding gas and dust and creating the dazzling light show that Webb is observing. This energy release is so powerful that it can outshine entire galaxies, making black holes some of the brightest objects in the universe. In some cases, the energy released can also power jets of particles that shoot out from the black hole at nearly the speed of light. These jets can extend for thousands of light years, influencing the formation of stars and galaxies far from the black hole itself. Black holes are not just destructive forces, they play a crucial role in the evolution of galaxies. By consuming matter and releasing energy, they help regulate the growth of galaxies and the formation of new stars. The James Webb Space Telescope is providing us with unprecedented views of these cosmic giants, allowing scientists to study their behavior and impact on the universe in greater detail than ever before. Through Webb's observations, we are gaining a deeper understanding of the fundamental processes that shape our cosmos. As we continue to explore the mysteries of black holes, we are reminded of the incredible power and complexity of the universe. These enigmatic objects challenge our understanding and inspire us to keep pushing the boundaries of what we know. Unlocking the secrets of black holes. The observations of Sagittarius A, the supermassive black hole at the center of our galaxy, has long been a subject of fascination and study. With the advanced capabilities of the James Webb Space Telescope, we are now able to capture images and data with a clarity and detail that was previously unimaginable. This allows scientists to delve deeper into the mysteries of black holes, exploring their properties and behaviors in ways that were not possible before. By studying the light show around the black hole, astronomers are gaining a better understanding of how black holes form, grow, and influence their surroundings. The light emissions, often referred to as the accretion disk, are composed of matter that is being pulled into the black hole's immense gravitational field. As this matter accelerates and heats up, it emits light that can be observed and analyzed. This process provides valuable insights into the dynamics of black holes, including their mass, spin, and the rate at which they consume matter. Additionally, the interaction between black holes and their surrounding environment can reveal much about the role these cosmic giants play in the evolution of galaxies. Black holes are still some of the most mysterious objects in the universe. Despite decades of research, many questions remain unanswered. How do black holes form? What happens to matter and energy that fall into them? Can anything escape their gravitational pull? These are just a few of the puzzles that scientists are trying to solve. The enigmatic nature of black holes continues to captivate the imagination of both scientists and the public alike. But with Webb, we're starting to unlock their secrets. The telescope's powerful instruments are capable of observing black holes in multiple wavelengths of light, from the infrared to the visible spectrum. This multi-wavelength approach allows researchers to gather a more comprehensive picture of black holes and their interactions with the surrounding cosmos. Each new observation brings us one step closer to understanding these complex and fascinating objects, and what we're learning is changing our understanding of the universe itself. The study of black holes is not just about understanding these individual objects, but also about gaining insights into the fundamental laws of physics and the nature of the universe. Black holes challenge our understanding of gravity, space, and time, pushing the boundaries of what we know and opening up new avenues of scientific inquiry. The discoveries made by the James Webb Space Telescope are helping to reshape our view of the cosmos and our place within it. This is just the beginning. The James Webb Space Telescope is set to continue its mission for many years, providing a wealth of data that will keep scientists busy for decades to come. Each new observation has the potential to reveal something unexpected, challenging our current theories and leading to new discoveries. The journey to understand black holes is a long and ongoing one, but with each step, we come closer to unlocking their secrets. Webb will continue to observe Sagittarius A* and other black holes in the years to come, providing even more insights into these cosmic giants. The data collected will be invaluable for future generations of astronomers and physicists, helping to answer some of the most profound questions about the universe. As we look to the future, the James Webb Space Telescope stands as a beacon of human curiosity and ingenuity, guiding us on our quest to understand the cosmos. A universe of wonders awaits. The James Webb Space Telescope is a testament to human ingenuity and our insatiable curiosity to explore the cosmos. Its discoveries are not just about distant objects in space, they are about us. They are about our place in the universe and the fundamental laws that govern our existence. The universe is full of wonders, and we are just beginning to scratch the surface. The James Webb Space Telescope is our eyes on the cosmos, revealing its beauty and secrets one observation at a time. This is a golden age of astronomy, and we are all along for the ride, so keep looking up.